some simultaneous equations. However, one of these is quadratic, so it's not like your normal elimination method or something, two straight lines that cross one answer. It is in fact going to be slightly more complicated. And before we jump into solving it, let's realize why it's more complicated by drawing our axes a bit more accurately. I'm going to actually draw roughly what's going on here. You don't have to, but 4x minus 1 will be a y equals mx plus c line that would go through at minus 1. It would look a bit like this, okay, just roughly. And then my 2x squared minus 7x plus 4, well, I know that it will go through at 4. I don't actually know for sure whether it will go through the axes, but let's assume it doesn't. It might come down like this, but then it will come back up and it will meet it. Oh, you can't see from this, but it will meet it again. So essentially, that was a really bad straight line. Essentially, we're going to get two solutions. We're going to get a solution here where the graphs meet, and a solution here where the graphs meet. There or thereabouts. The sketch is not necessarily accurate, but it illustrates the concept of what's going on. These red dots are solutions to the simultaneous equations. So how are we going to deal with this? Well, where they meet, the y values, so if we just look at this solution, the y values for the green line and the blue line are the same. And at this red dot, the same is true. I mean, it'd be different y values and the x values, in fact. But what I'm trying to say is that where they meet, these y values are equal. So it must be that this thing on the right-hand side equals the thing on the right-hand side below. And I can essentially jump straight into 2x squared minus 7x plus 4 equals 4x minus 1. I hope that makes sense why I can do that, because typically this is what you do whenever you solve quadratic simultaneous equations involving a quadratic. They could both be quadratics and you do the same sort of thing. It's a bit different if you didn't have a y equals, but I'm not going to go into that right now. So now I've got a quadratic, but I always, when I solve quadratic equations, I always want to make them equal to 0. So I'm going to need to minus the 4x, so 2x squared minus 11x, and I'm going to want to add my 1. So I've got a plus 5 equals 0. Now this is not particularly nice. This is a non-calculator question as well. I'm going to bet that this factorizes. I don't think we're going to be asked to use the quadratic formula in a non-calculator paper. We might be, but let's see if it factorizes. If it factorizes, then for sure I'm going to need a 2x here and an x here, or the other way around. Okay, but there's no other combinations that would work. And then I'm going to need two numbers here and here that multiply to give 5, and they're going to combine with the 2x and the x in such a way to give minus 11x. It's not that these two are going to add to give minus 11 because of this 2. So I need to just think about this. And what I'm just going to do, actually there's only two numbers that multiply together to give 5, although they could both be, actually they're going to have to be negative. Because I've got a negative here, it's either going to have to be minus 5 and minus 1, or minus 5 here and minus 1. I'm just going to say that again. I need two numbers that multiply to give 5. Like if it's going to factorize, they're going to be whole numbers. It's going to be 5 and 1, but they can't both be positive, because then there's no way I could get that minus 11x. So it must be they're both negative, so I've jumped straight to this line. Now I'm going to work out what happens if I was to multiply that 2x by the minus 5, then I'd get minus 10x. And if I multiply that minus 1 by the x, I'd get minus x. And I can see that this one works because that equals minus 11x. I don't even need to try this one now. It wouldn't work. So I'm done, essentially. I can write in that this is going to be minus 1 and this is going to be minus 5. When I say I'm done, I've still got some steps to do, but I've done the factorizing of a quadratic that doesn't have unitary coefficient, we say. All right. What do I do now? Well, either this bracket is equal 0, so 2x minus 1 equals 0, in which case I add the 1, I divide by 2, I get x equals a half, or x is going to be positive 5, because x minus 5 would equal 0. So I've got part of my answer now, I'm either going to get half, which would be this solution here, or I'm going to get 5. It looks like my sketch is not, it's pretty good actually. Okay, how do we finish it off? I need the y values. So for this, we do what we do with normal simultaneous equations. I say normal linear simultaneous equations. I need to substitute my x value back in. And it would be easiest to substitute it back into the simplest one. I don't want to be squaring it and stuff, squaring a half. Let's just put it back into the y equals 4x minus 1. So y will equal 4 times a half minus 1. And that's going to be 2 minus 1, it's going to be 1. So when x is a half, y is equal to 1. Do the same with the other one. Y is going to be 4 times 5 minus 1. That's going to be 20 minus 1. That's going to be 19. And we have successfully found the coordinates where these two graphs plot, which I just think is amazing. If you don't think it's amazing, then I'm sorry to hear that. But, you know, ultimately, we set these two equations equal, we solve a quadratic, in this case it factorizes, we substitute it back in to get y, and we're done. Make sure you can do that.